the ASIPod related topics. So this presentation is like a webinar. It's made for educational purposes. So whatever we tell here, please refer always to product manuals and vessel specific instructions from ABB. And if in any doubt, please contact us and then we help you forward. So in this presentation, we have 5 sections. First one is the definition of stacking. Basically, what classification societies talk about the stacking. Then we have recommendations for propulsion systems during operational break in the short-term breaks. And then third section is consideration for the code layup, which means basically longer period of stacking of the vessel. And then in the fourth section, we concentrate on the ASIPod related considerations. And then in the end, in the fifth, we have questions and answers section where we answer the questions that you have submitted to us in the chat window. So in general, when this unfortunate event happened on the cruise industry, ABB made service bulletins to help the operators to go through this layup and operational breaks for the vessels and end up in the situation where all the equipment is still in good condition to start the operations once everything is over and back to normal. And we have made 2 bulletins, one for warm layup and one for cold layup, referring to short and long-term breaks in the operations. And those instructions, they describe actions in general level for ABB products. And like I said before, please refer to the product manuals and for further instructions from ABB when you are taking actions to stack the vessels. And if you have not received the service bulletins and you still have ABB equipment on board, please contact your local Marine Service Center, or if you have allocated account manager from ABB, contact them and they are happy to share the bulletins with you. Just as a reminder, ABB Marine Service Network, a global footprint. So here you can see the red dots where are the Marine Service Centers. Just a reminder that if you are any of these areas, where you find the contacts. And when you go to the web page that was given in the previous slide, you find detailed contact information. So next couple of slides, they refer to the classification society instructions, how they define the stacking. First, we have here Lloyd's register. Lloyd's is more detailed in the instructions. Like for hot ship layup, they have 2 different kind of approach. One is for 24-hour reactivation, meaning that vessel is basically in operation. The crew can be on the minimum safety manning limits, and some other adjustments for the operation can be done, but the vessel is ready to start the operation basically in 24 hours. Then another option is that the vessel is laid up for, according to Lloyd's, 12 months out of service, which is of course instruction. It's up to the operator and the owner to make the business decisions what is the best for the vessel, best for the operation. But this longer hot layup can have like a 1-week reactivation time, meaning that then the crew is reduced even more, and but the vessel is still like in the operational condition, basically anchoring, but can leave the anchoring position and move if needed. And then there is a warm layup with 1 week reactivation time as well, but with the difference that typically the vessel is moored in the port. And it can be recognized as a layup or laid up condition from the class point of view. And then Lloyd's has also cold ship layup, which means that the vessel is basically switched off. Only the mandatory auxiliary power is available, and only minimal crew, whatever is needed for the emergency requirements. And the reactivation time can be like 3 weeks. And then DNV. DNV is a little bit more simple in the instructions. There is a hot layup, which means that the vessel is still in operation, but it's with the reduced crew aboard. And it's pretty fast to recommission and take back into operation. And then there is a cold layup, which means that the vessel is out of service, and it's called electrically dead. Of course, some auxiliary power is needed, like we refer in the future slides, what is required to keep the equipment in good condition and make sure that after the layup condition, vessel is possible to start up again with the minimal damage to the equipment. Then in the next slides, we go more to the ABB's instructions, what is given in the service bulletins. And the first section covers hot and warm layup condition. So in general, these are recommendations for practices during operational breaks. And the first service bulletin, which reference number you see in the bottom of the screen, that is not valid for long period of inactivity, which is then called cold layup and has its own instruction. The most important things in all layup conditions are temperature and humidity, mainly from electrical equipment point of view, what we are considering here, since it's ABB's core products, and then some other details for the Azipod, which is then turning more to the mechanical side. Basically, two major things that kill the electronics is a high temperature and high humidity. And those two things need to be taken care. Of course, also corrosion on the mechanical side, like shots, that kind of thing, need to be considered, but that's not so critical as it's for the electronic boards. From safety point of view, always refer to product-specific electrical drawings and manuals. That should be the source of information. Then, very important safety topic. When the system or part, especially if the part of the system is switched off, you have to make sure that when you're working on the equipment, is that part something that there is no power, or is there power? There can be electricity, you don't see it, you don't smell it, but when you touch, you feel it. And now when the partial system is switched off, it's very difficult to know what is on, what is off. And that's why all kind of lockout, tagout procedures are extremely important in this kind of not normal situation. All kind of tapes, lines to block out the equipment which has power, which don't have power. That's very, very important. Don't assume that there is no power. As a continuous request for the warm and hot layup is that air conditioning should be on to keep the temperature and humidity in the acceptable level. UPS power supplies should be on to have a power supply for the electronics in all kind of equipment board. Also, the auxiliary voltages should be on if like a cooling fans are needed or water pumps need to be rotated. And then heaters should be on to keep temperature a little bit higher inside the equipment than what is outside to avoid the humidity to come inside. And LT water circulation should be on as well. And as a continuous request, the room air conditioning should be checked that it's on. It's kind of a normal routine in general in the vessels, of course, but it should continue also in the layup condition to make sure that in case of failure, there is no air conditioning in some areas. UPS power should be on. Auxiliary voltages, like mentioned, should be on. Heaters and LT water. Everything should be running as normal. Of course, consumption is less, so there should not be too much worried about the energy efficiency or that kind of thing in the auxiliary or UPS powers, because there is not so much consumption ongoing when the vessel doesn't operate. And then on the vehicle checks, basically those things that was mentioned already for the continuous checks, they need to be checked. They should be recorded as well to make sure if there's anything abnormal happening, that is recorded, what happened, why it happened, and what's the plan to fix it. What was not mentioned earlier was main switchboard. On the main switchboard, the auxiliaries should be on, and all the protection relays should have power, especially if there's power in the main switchboard. It's natural that the whole system have to be operational. And same comes to the remote control units, RC-pod interface unit or SQ units. They are all electronics, and they should be running as normal when the vessel is in warm layup condition. And then the weekly checks continue on generators. Generators should be used regularly. It's a mechanical equipment, and it's meant to be running and rotating. And if there's no rotation, there will come damages to the bearings. There comes corrosion and that kind of thing. So it's good to be rotating the running generator so that all of the generators have been used in weekly basis. Also, LT water circulation should be on. Heaters should be on when the generator is not in use. Normal air conditioning, ventilation in the engine room, like in the normal operation. Bearing oil level need to be checked that it's in normal level. And if the generator has not been used for 3 months, then the rotor should be turned at least 10 times in every 3 months. And remember, when rotating the shaft in slow speed, use the jack-up pumps if there is one in the generator. Transformers, a little bit easier. There's not much moving parts, but there is winding, and that winding requires that the humidity is not increasing too much and get the winding wet. And that's why heaters should be in use, and the transformer cooling fans should be rotated like 2 hours, 2 times a week is a good practice. And then change the duty fans each time so that all the fans have been used in a weekly basis. And if it's a liquid cooled transformer, then the same need to be done for the cooling pumps. And when the cooling pumps have been used, also the LT water circulation should be on. Propulsion converters and propulsion control units, those are critical items. They are full of electronics. So there have to be extra careful that the humidity is not increasing and temperature is not increasing in the electrical rooms where they are located. Typically, propulsion converters are water cooled, and then the water circulation should be used regularly. Normally it starts automatically, but if not, then it have to be started manually. Again, in in weekly basis, 2-3 times per week, just to have a rotation of water inside the pipelines. And if that is not done, the water start to get all kind of bacteria and start to grow some weeds and all kind of stuff, which then is difficult to remove afterwards. Propulsion motor, it's same like a generator. The shaft need to be rotated every now and then. And when rotating the propulsion motor, of course, remember that there is the shaft line behind, so you need to take care of all the shaft line bearings, shaft seals, and all that as well. Then the next section, we go to code layup, which in the classification society's definitions mean a longer time the vessel is out of service. And typically no electric power in the system. So the vessel is cold from electrical point of view. Main ideas in the code layup are that the vessel is, or the systems are turned off. Pretty much all the systems can be switched off, except auxiliary powers for some equipment that need to have power. And then for all the equipment, we have identified some kind of major risks, and they will be presented in the following slides as well. And in general, laying up code in long period of time without use, it increases the mechanics exposure to corrosion and possible hardware failures for electronics, especially if it's obsolete equipment. So it's very important to have a ventilation in use and also have a clean equipment. And then anti-condensation heaters should be used, which then of course the auxiliary power as well. For the preservation, also to protect mechanical systems, there is chemicals available that can be used to treat the surfaces to avoid corrosion. And if you are in need of those, ABB have also procedures how to do it, and we are available to share information when needed. Like mentioned earlier, obsolescence is one important thing in the code layup. If the equipment was obsolete already before going to layup condition, during that time, if it's years, the obsolescence is getting even worse. There's even less components available afterwards. There's even less competence to fix those systems afterwards. But even more important thing is when you switch off old electronics, there is high risk that it doesn't start up again. Especially if the system has been switched off for a longer time of period of time, the capacitors tend to dry, and when you switch on power again, they start to blow up. Can be random failures here and there. Capacitors blow up and then get all kind of strange behaviors in the system. And that's kind of general rule for all the electronics, not only in the layup condition. And in order to be prepared for this kind of condition, there should be available the spare parts. If there's foreseen any plans to take the vessel back to operation after layup condition, and we already know that the equipment is obsolete, it's better to be prepared with the spares for the future, if they are available. If it's already obsolete, it might be that there's difficulties to find all the needed components. Then we go through the equipment. So first we have generators, AVRs, and NP resistors. For generators, same instruction like for warm layup, the shaft need to be rotated every now and then, at least in every 3 months, 10 revolution for the shaft, and using jack-up pumps. Auxiliary power should be available for turning gear in order to do these rotations, and in order to use the jack-up pumps, and also to have the space heaters. Otherwise, there is no need to have any power on the generator, but the auxiliary power is needed for space heaters continuously and for other equipment when they have been used. And then corrosion monitoring and protection on machine and bearings. That's important. And especially for generators and the shafts, some mechanical components, there should be used the chemical inhibitors on the shaft to treat the surfaces to avoid any corrosion there. And then it's good to make insulation resistance measurements every now and then to keep track of the condition of the winding, especially if there is a problems with the temperature or humidity on board. Then it's more important to have a track of level of insulation in the winding. And then vapor corrosion inhibitors inside the cabinets need to be replaced when they're getting old. That's mainly for the AVRs. And for AVR in general, it's important to keep the heaters on so that there is no humidity coming inside, but then at the same time keep control of the temperature that they're not getting too hot. For preservation, for some equipment there's needed this temporary power supply, like mentioned before. And all hatches should be closed, all opening, and then dehumidifiers used inside cabinets, inside the equipment, to make sure that inside there is the equipment's own atmosphere where the humidity is less than what is outside. For AVR, especially for unitrol and new type of equipment where we have like a computers, it's good to take backups of all the settings and softwares to make sure that whenever we need to restart the system, we have the latest parameters available, so that we don't need to start to do the recommissioning again. And then auxiliary power can be switched off for AVRs. Main switchboard. For follow-up and maintenance, it's good to operate the breakers 2 to 3 times every 2 months, so that there is a movement in the mechanical parts of the breakers. Otherwise, it's more like a visual inspection for moisture and corrosion, and the replacement of vapor corrosion inhibitors when possible, or when needed. For the preservation, it's good to make insulation resistance measurements again to see what is the insulation condition of the equipment. And then breakers should be racked out and bus bar earthed when there's no power anymore in the switchboard. And closing springs on the breakers should be released so that they don't remain in a tension for years of time. Of course, if the breakers have been operated 2 to 3 times every 2 months, then it's not that big problem if the spring is not released. But when it's left for a longer period of time, it's a must that they need to be released. For the protection relays, softwares and parameter backups need to be taken again to have the latest situation, what it was when the system was switched off. Otherwise, all auxiliary voltages can be switched off, but the space heaters again need to be on. One highlight on the risks is are the signal transducers. Those are known to be a little bit sensitive for power outages. It depends on the manufacturer and age and all kind of things, but in general, it's possible that when power is switched off and then after some time switched on, the signal transducers can fail. So special attention on those, mainly to have the spares when they have been switched off. The UPS is it's also electronic system, so same considerations there. Temperature within the limits and humidity in acceptable level. And again, vapor corrosion inhibitors need to be replaced when it's time. And otherwise, visual inspection once per 3 months. And for preservation, again, backups from all the softwares and parameters where is applicable, of course. And then after all the equipment what this UPS is supplying, after all of them have been switched off, then the UPS itself can be switched off. And battery is a special thing in the UPS, and those must be handled according to the battery type. There is a lot of different type of batteries used in UPS, so it's not possible to say one way of handling the batteries. So always please check what type of battery, how to handle it. Some need to be switched off or disconnected, some need to remain connected, some might need to have a charging available to keep the energy inside, and so on. And again, use the corrosion inhibitors where applicable and close all the openings. Transformers. So for the transformers, all the powers can be switched off. They can be in cold state, but again, space heaters, they need to be available, or the power for the space heater need to be available, and power for ventilation fans and oil circulation pumps when they have been used. Otherwise, insulation resistance measurements need to be done and recorded. And then when the propulsion drive is ACS 6000 SD, remember that the main cablings need to be disconnected if you want to measure only the transformer. For the follow-up and maintenance, the cooling fans need to be used at least once per 3 months. See that all the fans are working, they're running, and there's no any strange noise or anything coming out from them, and to have some movements for them. That's a mechanical equipment, so they need to move every now and then. Same for liquid cooled transformer, oil pumps, or the liquid pumps, they need to be rotated once per 3 months to put the oil inside the transformer moving. And then especially important on the liquid cooled transformers is to check that there is no any leakages happening. If there is, they need to be fixed. And then dehydrating breathers need to be checked, and oil filled in the cup underneath. And then of course if the breather is getting old, then replace as needed. And then for condition monitoring of the liquid cooled transformer, oil sampling should continue in the once per year frequency, like it was in the operation. Then propulsion converters. ACS 6000 SD, ACS 6000 C mentioned. Also, it can be ACS 800, 880 low voltage drives. Basically, same consideration apply also for those. So water pumps need to be rotated every now and then. In the preservation side, you can see that the cooling water should be drained out of the system. And the cooling system should be cleaned by flushing air so that there is no any dust or anything around. And also external water, LD water circulation should be drained. And those are extremely important if the vessel is in the cold environment, so that there is no any ice coming in the system. Maybe not that relevant for the operational vessels or vessels that have been in operation, but this has been very important for the new build periods when the equipment has been at the yard to avoid any ice in the water system and ice breaking the pipes and seals. And space heaters, they need to be on. Otherwise, power supply is not needed. So all the power can be switched off from the drives, and only space heaters left on. And even for cooling fans or cooling pumps, there is no need to have power available. Those can be rotated by hand, just to have some movement for them, so that they don't get stuck. And for the 6000 SD drive, the DC link should be grounded, and motor output as well. And on the C, the cycle converter, the high-speed breakers should be open. And of course, general earthing instructions need to be followed to make all the systems safe to touch, safe to work on. And all the labels, lockout, tagout, like mentioned before. Very important when you cannot be sure where is power, where is not power. Soft line motors, AM jet propulsion motors, very similar to the generator. The shaft need to be rotated manually once per 3 months using the turning gear. And basically 10 revolutions once per 3 months. And again, if there's jackup pumps, those need to be used. And again, with the propulsion motor, have to remember that there's soft line behind. So you need to take care of the possible gearbox, soft line bearings, soft seals, the whole chain which then moves when the propulsion motor is rotated. And again, corrosion monitoring and protection for the machine itself and for bearings. And space heaters need to be on. And again, space heaters are the only auxiliary power that is needed for the propulsion motors. And all hatches, openings, everything keep closed, and use the dehumidifiers to keep the humidity inside in acceptable level. And then propeller shaft should be locked to avoid windmilling if there is a current coming from outside. Then remote control systems, propulsion control system, automation in general. Automation itself requires specific planning, and for that, depending on the system, there is different ways of doing it. And if you're planning to switch off the automation, please contact us, and we will make the plan together how to do it in the safe way. And depending on the vessel condition, some level of operation might be needed from the automation. It can be that it's not possible to switch off completely. But automation is electronic equipment system, so their humidity is important to keep in control. So vapor corrosion inhibitors need to be replaced in the cabinets frequently. for the preservation, the relevant backups have to be taken from the propulsion control system, remote control system, automation in general. There is a risk that when power is switched off, the CPUs lose their memory and they lose the last software version in the system. And to be prepared for that, then we need to have backups available. And that relates to all the controllers, servers, clients, Ethernet switches, RDS computer, all the equipment where we have softwares and parameters in use. And after that, backup batteries can be removed from the controllers, especially if it's a long period of time to be planned on layup. Batteries lose their energy anyway, so it's better to remove them so that they don't start to leak or anything. And then after that, all computers can be switched off. Auxiliary voltages can be switched off. That was the electrical side and automation side. And next we move to the ASIPAD related considerations. And I moved the seat to Jim.
Yes, thank you, Teemu, and good morning or good afternoon to our audience. My name is Jim Kruger, and I will be discussing some of the specific considerations for the ASIPAD propulsion units. As you know, many of the items that Teemu just covered also apply to the ASIPAD units as well, but because the ASIPADs consist of both onboard and underwater components, there are a few additional things to think about. And also, as Teemu mentioned, the most important thing is safety. Unfortunately, it's just too common that during partial shutdown situations, people sometimes assume that everything is powered down and safe. You must never make this mistake and always need to follow proper lockout, tagout, and other procedures carefully. So with that, let's talk a little bit about the ASIPAD units. Teemu did a wonderful job kind of covering over the electrical components, and many of those things are common to the ASIPAD. Of course, we have the low voltage electrical supply, we have LT cooling water, we have the AC system primarily within the ASIPAD room, and of course we have monitoring stations to monitor the health of the ASIPAD. And hopefully those stations are at least partially manned during a shutdown situation. And lastly, we need to do some periodic service to make sure that the ASIPAD system remains as healthy as possible. Next slide. So starting off with the LV electrical supply, with respect to the ASIPAD, the LV electrical handles a lot of the monitoring and support functions. And generally, we recommend that those systems remain powered up. It's, of course, a lot easier if the ASIPAD monitoring systems are powered up, and thus those protections are in place. And furthermore, we have some very critical things. Because the ASIPAD system sits in the water, there is a risk, of course, of leakages. And for example, if the bilge pumps are shut down and a leakage were to occur, then unfortunately the ASIPAD would fill with water, and nobody wants to have a situation like that. So if we can keep some low-level LV power on, it would be much better for the whole system and the ability to start the system up once the time is right for that. Next slide. So as I said, the mitigation would be to make sure that we keep the LV power on for the AIU and the oil circulation, so that we keep the bearing oil healthy. We keep the programmable automation components powered up, so again, we don't run into the problems of losing software and whatnot. And lastly, we have to make sure that we have all software and parameters backed up just in case something were to happen and we do lose the LV power and lose backup systems such as UPS or even onboard RAM. Next slide. When talking about the air conditioning within the AZIPod room, it's quite important that we try to maintain proper temperature and humidity balance within the AZIPod room. And as Teemu had mentioned, one of the biggest enemies of electrical components is heat and or humidity. And so the best way to make sure that the heat and the humidity is not an issue is to keep the AC system running during any kind of a shutdown period, whether it be short-term or long-term. Oftentimes, once an AC system is shut down, particularly in spaces in the vessel that they're in contact with the water, condensation quickly ensues, and we start having all kinds of problems that sometimes are very hard to troubleshoot, particularly with items such as electrical contacts and those kind of things. Once the contact surfaces become corroded, then the contact is unreliable. It may be making intermittent connections, it may not be. And again, those are very hard to troubleshoot often. So again, the recommendation would be to keep the AZIPod room air conditioning running at all times. Next slide. And again, yes, the mitigation would be keep the AC system running, keep a temperature and humidity log, and to make sure that it's not getting out of control. We do recommend still to do the periodic oil sampling. And there may be a need to do some kind of drying actions on certain equipment prior to reapplying the electrical power when the time is right. So in the case where humidity levels were high, typically insulation resistance will go down. And if it gets to a critical point, then of course it's not recommended to re-energize until we can get that insulation resistance back to an acceptable level. And one way to do that is to keep the space heaters on when possible. And in extreme cases, we may need to do additional mitigation actions, such as using additional heat or air drying equipment before the power up happens. Next slide. I think Teemu mentioned a little bit about the loss of LT water. So the low temperature water circulation is important in the AZIPod for cooling of certain components, including oil temperature or oil lubrication systems and those type of systems. The concern is that if the LT water circulation is shut down and there's still water in the system, then bacterial growth will quickly ensue and or sediment can happen. And unfortunately, the small areas within the heat exchangers can get plugged, and that will be an issue on the restart. Next slide. On the next slide, I think, yes, we mentioned that if the LT water circulation is stopped, then we recommend to drain the circuits if it's going to be for long term, or there are chemical treatments that can be added to the water. Of course, chemical treatments have to be carefully considered because some may be corrosive to certain components within the cooling system. So it's one of those things that oftentimes chemicals can actually cause additional problem. Next slide. And lastly, we have to seriously take into account periodically exercising the equipment. equipment's not unlike people, and if you're not moving very much, it becomes very hard to start moving once the time is right. So what we need to do is we need to consider particularly the bearings. If the bearings have been in long-term stationary positions, it will have an adverse effect on the metallurgy of the bearing itself. In some cases, flat spots can even start to form on the rollers. In extreme cases, because in these cases the propeller is still on the shaft, and if the shaft hasn't been turned in quite some time, that's quite a lot of weight. And in extreme cases, it's even possible to have a bent propeller shaft if it hasn't been rotated in long periods of time. So that's quite important for the bearings and for the shaft. Seal systems, of course, must be exercised. What happens with the seals is most seals need some type of lubrication in order to properly slide on the surface with which they meet. And if the oil or water that happens to be lubricating that seal hasn't been exercised into the seal surface in quite some time, then of course what happens is the seal almost welds itself to the surface. And what will happen in that case then, of course, is when you first turn, then even microscopically little pieces of the seal lip will pull away and lead to eventual seal failure. In extreme cases, it can be almost immediate, where the seal tears itself if it's been stuck to the surface for too long. A couple of other equipments include the carbon brushes. The carbon brushes, of course, need to be moved periodically so they don't get stuck to the surfaces with which they meet. And lastly, items such as brakes, they may get stuck in the open or closed position if they've been in those positions for quite some time. As with any mechanical device, corrosion can quickly ensue, and again, if it's not been exercised, that leads to failure rather quickly. Next slide. So again, I've been discussing some of the mitigations, but we need to periodically run or turn the propulsion shaft with the proper oil circulation and condition monitoring. We should periodically turn the seals. Whenever we're going to periodically run in service and do a complete propulsion start, we would recommend to run briefly at a low RPM, say 20 to 30 RPM, and to rotate the steering complete 360 degrees, maybe even multiple turns as practical. But please remember that when we do this, we have to have oil levels set to the proper levels, and we should have all the monitoring systems in place. So we shouldn't be trying to run this without the monitoring systems on, because we may be causing other problems that we're not aware of at the time. If it's determined that it's not practical to turn the AZIPod by repowering, it can be turned manually. In the case of the AZIPod shafts, we would recommend to turn the shaft at least 3 revolutions every month. Of course, don't stop it back in the same spot that it was in to avoid the shaft bending that I had mentioned earlier. And most vessels have a turning gear which can be used to turn the shaft. Others do not. Of course, those that don't, it's a little more difficult to turn that shaft, but it can be done using chain hoists or come-alongs within the AZIPod. Again, it can be done. It's not the easiest procedure. So it may just be more practical to restart and to turn via the electrical system. And with that, I believe that's the end of our presentation. And so now we will be going to a Q&A. Let's see here, there's a few questions pouring in, and I will read those. And I guess then either Teemu or I can go ahead and answer those. So first question is, during warm stacking, can all equipment be shut down, excluding the automation, or is there a need to run some equipment periodically, for example, weekly? So as I had just mentioned, certain equipment should be turned periodically. In the case of the AZPOD units and the seals, we would recommend that they would be turned, say, once a month. I know on some of the other equipment, Teemu, you had mentioned, for example, the generators, I believe it was every 3 months to rotate.
Yeah, in the warm up or warm layup condition, based on the definition, the vessel should be in possible to take back in operation in a relatively short period of time. And having that consideration in mind, power can be switched off from equipment that is not needed. Let's say a propulsion drive. If the vessel is moored in the port, there is no need to have a power inside the drive, and it's relatively fast to get back to running condition, especially when we are talking about the new drives that are in active life cycle status. But when we are looking for old equipment, possibly even already obsolete equipment, like mentioned in the presentation earlier, there is high risk that when you switch off all the power and you start it again, switching on power for all the power supplies, there is a risk of damaging some electronic equipment. So for older equipment, have to be really careful before you take any actions to switch off power, especially if it's only short period of time that vessel is in warm layup condition. And why to switch off all the power? Of course, can be that there is no power available for certain areas, certain fire zone or something like that. Then of course need to be switched off. Otherwise, from energy consumption point of view, the consumption is pretty small in equipment that is not in use, which is only in standby. So before you switch off, you need to consider what is the benefit and what is the risk if you are doing so. And then talking about the layups and how long time to be in the layup, how long it takes to start up the system afterwards.
Okay.
Jim, was there something else?
Yes. Next question, there's a few questions coming in. One question is, how do you turn the shaft 10 turns?
If the question is related to generators or propulsion motors or soft line motors, typically those equipment have a turning gear, and then if there is or there should be power available for the turning gear, which is then used to rotate the shaft. And 10 rounds, it's just the instruction. It's good average. It can be more, can be few rounds less. It's not that accurate, but the important is to get the shaft moving, get the oil flowing inside the bearing, and so on. And in case of generator, which is connected to the engine, then of course when the generator is rotated, also engine is rotated. Or if engine is rotated, then the generator rotates at the same time, unless the clutch is opened, which then of course then need to rotate them separately. Same for the propulsion motor with the shaft line. When the propulsion motor is rotated, in the best case with turning gear, the whole shaft will rotate unless they are separated. And if there is no turning gear available, then you can always use lifting ropes that you put around the shaft, and then a chain block to pull in order to rotate the shaft. So
Yes,
there is also a manual way to do it.
And then similar for the AZIPod, of course, most have a turning gear. And as I had mentioned, similar to what you mentioned just now, Teemu, we could turn them by hand as well with slings and chain hoists and whatnot. Although that's a much more difficult manual method to do. Still can be done. Let's see. Here we have how different will product be developed in the future considering the epidemic, namely COVID-19? Will products be designed such that maintenance is not required unless breakdown?
I think it's quite a big question. I would say that in overall the product development is not looking too much on this kind of epidemic situations or special conditions, but in overall, as part of the product development, of course, the maintenance need is one consideration, and the target always is to reduce the maintenance needs. But then to have a target of zero maintenance on a mechanical or electrical equipment, it's quite the ultimate target. Really difficult to meet. I don't know, Jim, do you have something from the AZIPod point of view?
I agree with what you said there, Teemu. Specifically when thinking about worldwide pandemics such as disease like this, it's a situation that I think is too rare, too infrequent to be much of a design consideration normally. Of course, I think product developing often tries to take into account maintenance. I don't think that it's very often thought, however, to mitigate against long-term shutdowns and whatnot. But having said that, I think certain equipment, say for example, dry type transformers, are more or less maintenance free, and just by the nature of their design, they're pretty well protected during long-term shutdowns, provided that they're maintained within the design limits of temperature and humidity and dirt and that kind of thing. So I guess maybe a little bit of a loose answer, but it's a yes and no kind of answer.
Yes, thank you guys. Just want to jump in. We are running out of time and have now come to the end of our ABB TechTalks session. I want to give a special thanks to our presenters, Tim and Jane, for sharing all your knowledge with us. I also want to just send a quick reminder, if you still have any specific questions regarding stacking of your vessel, please contact an ABB expert at one of our contact centers. We'll share the webpage with you. And again, thank you everybody for participating. And this concludes our ABB Tech Talk for today. Have a great day.